Good afternoon, dear students. Yesterday class, we learned that the introduction of thermodynamics and what are the application of thermodynamics, then what is surrounding system and types of system under physical and chemical properties. Today, we are going to study types of system. It is one of the important question, and the types of system are categorized by nature of boundary. Okay, so in the previous class you learned also one type of system. It is it is categorized by the physical and chemical properties of the system. So it is divided into two types, that is homogeneous and heterogeneous. Okay, today's class we study the same one types of system, but it is depend upon the boundary of nature of boundaries. Okay, nature of boundary. So by dividing the system depending upon the nature of boundary into three types. So what are the types? Open system. First type is open system. Second type, closed system. And third type is isolated system. So by the classification of system by depend upon the nature of boundary, divide into three types: open, closed and isolated system. So how open system will be in the universe? You can take any other compound in a test tube, like test tube. Okay, now this is a open system. So the mouth of this test tube is open. Okay, it is an open one. Then what is closed system? Mouth of the test tube is closed. Okay, it is closed. This is closed system. And what is isolated system? Isolated system means test tube which is closed, mouth of the test tube which is closed, and it contains some constituent, and it is kept in one thermo system. That means it's not allow heat from the outer side to inner and inner to outer. That means there is no transformation of heat or any energy. Okay, that is isolated system. You can see that in briefly. Open system. Now take a beaker with water for understanding the open system. Beaker with water. Now the water contained beaker is heat and it get boiled. Now what will happen? What is happening during this heating and boiling of this beaker or any system? Okay, this system. So what will happen when you add or when you transfer the energy or heat from a source, then this water molecule which is present in that system which is absorb the heat energy. It's absorb the heat energy. So there we have exchange in energy. Okay, exchange or transfer in energy. Okay, exchange in energy you can write. So open system means a system can exchange the energy. Because of exchanging this energy, the water molecules get boiled. Because of this boiling process, water molecules of that boiling water, they are evaporate. Okay, so some water particles are evaporate and it is mixed with the surroundings. So it is mixed with the surroundings. So what is going on during this open system under the thermodynamics condition? What will happen? This is exchange its energy and also exchange the particles or the matter which is present in that system. It is exchange with the surroundings. Okay, so exchange in energy and matter. Matter with its surroundings is called open system. So what is open system? A system which can exchange energy and matter with its surroundings. It's called open system. So what are the particles are exchanged with the surrounding by the system? Heat and matter. That means water particles are mixed with the surroundings, and heat energy also it is transferring from the surrounding to the system. And from when you leave that or when you remove that source of heat from that system, then again that system will release some energy to the surrounding. It's lost its energy with the surrounding, with the atmosphere. Okay, so exchange of energy and matter is called open system. For example, hot water contained in a beaker and it is in an open system. So they can exchange both the heat or the energy and matter. Okay. When you study the open system, then you should remember that heat exchange with the energy and matter is open system. So all the living things, metabolic reactions and living things reactions, chemical reactions are going on in the universe. It is an open system because they exchange their energy and the matter with the surroundings. So they are open system. And the next system is closed system. Closed system is the second type of system from the types of system. To understanding this closed system, you take water containing beaker. Take a water containing beaker. The mouth of that beaker which is closed. Mouth of a beaker is closed. Okay. Now this system is absorbing the heat energy from the surrounding. This is a closed system. When you boil this system, the water particles which is present in that system will evaporate and it is not released into the environment. Okay, you can see that because the mouth of that beaker was closed. So because of this closed system, the water particle which is present in that beaker, it's not released into the environment. So all the water particles are present in the inside of that beaker. So there is a transformation of heat, only transformation of heat, not transformation of matter or any other constituent which is present in that beaker or the system. Okay, we consider this is a system and the system contains some constituent. It's absorb the heat energy, or the system is absorbing or transferring of heat energy from the surrounding to system is possible, and from the system to the surrounding it is also possible. So there is a possibility of exchange only the energy, but there is no possible, it is not possible to exchange the matter exchange with the surrounding. It is not possible. Okay, now we can see this one. When you remove the source of energy, source of heat from the system, then you can observe that the system temperature will be reduced. Why it is reduced? We are not applying any force, or we are not working, not work is applied on this system, but it is released its energy or its heat energy with the surrounding. What are the system? You can imagine that when you keep a hot water in a in a in a glass or any bowl or anything, hot water, then you leave that for half an hour, then you can after half an hour you can see the temperature, is it same before that half an hour when you keep that bowl into the room temperature? No, it will not same. Why? Because the exchange of energy with the system and surrounding. So the system is released its energy. Energy means heat into the surroundings. So there in the closed system, when you close that bowl with any lid or anything, then you can observe only the heat is released, but all the water vapor are present in the lid of that bowl. Okay, so there is no exchange of matter, but there is the exchange of heat energy or the heat. Okay, so in the closed system, a system can exchange only the energy but not exchange the matter with its surrounding. It's called a closed system. Here the boundary is sealed, but it is not insulated. Boundary is sealed. Okay, so it is sealed, only it is closed. It is not isolated. Isolated means you know that the next type. Okay, so it is the closed one. Okay, so this is one of the examples. Hot water in a closed beaker, it is also an example. So there is only a heat energy transformation, no transformation of matter. So the absence of matter is escaped from the system. It is in the closed system. Third type of system is isolated system. Isolated system. In this isolated system, it is different from the previous two systems. It is totally isolated from the surrounding. System is totally isolated from the surrounding. That means there is no transformation of energy. That means heat. Okay, so there is no transformation of heat energy and no transformation of matter from the system to the surrounding. So what is isolated system? The system which cannot exchange matter and energy with its surrounding is called isolated system. No exchange in matter and energy. For example, isolated system, when you take thermoflask, we use thermoflask to heat, to keep the hot water in the same temperature. So that is thermoflask. You are using this in your home. You are using this, and some are keep this with you for taking water, for taking to carrying hot water or any type of temperature water. Okay, so the isolated system is using to limiting the exchange. Okay, so it's not allowing, the thermoflask is not allowing the heat energy from inside to the outside of the system. You take, this is thermoflask. Inside that thermoflask is filled with water. It may be hot water or it may be hot or cold water. You kept that in the thermoflask. Because of using this thermoflask is not allowing the heat from inside to outside and outside to inside. That means from system to surrounding and surrounding to system. Okay, it's not allowed. So there is no transformation of heat energy and also no transformation of matter from the system, from the isolated system with its surrounding or with its environment. So you learned that 3 type of system. Next one, what are the properties of system? So what are the properties of the system we have to know to understand this thermodynamics. Properties of the system. So the properties of the system are considered here into 2 types, intensive and extensive properties. So how we classified into intensive and extensive property? Some of the system are depend upon the mass and size of the system. The properties which is depend upon the mass and size of the system is called extensive property, and it is independent. The property is independent of the mass and size of the system are called intensive property. So intensive properties means independent of mass and size of the system. Then what is extensive? It is opposite. Depend on mass and size of the system. It is extensive properties. So we have some list of properties of intensive and extensive with in the system. For example, volume, number of moles, mass and the internal energy. These are the extensive properties. And some of the example for the intensive properties are refractive index, surface tension, density, temperature, boiling point, freezing point and molar volume. These all are under the intensive property because they are not depend upon the mass and size of the system. But in the extensive property, it is depend upon the mass and size of the system. Volume is, it is depend upon the size of the system, and number of mole means it is depend upon the mass and size of the system. Okay, so these are the intensive and the extensive property. We have some list of properties in intensive and extensive properties. They are given listed here: volume, mass, amount of substance, that means mole, energy, enthalpy, entropy, free energy, heat capacity. These all are extensive property. That means it's depend upon the mass and size. Okay, it's depend upon mass and size. Mass or size it is depend upon. And the extensive property, molar volume, density, molar mass, molarity, mole fraction, molality, specific heat capacity. These all are under the category of intensive property because this is not depend upon the size or mass of the system. Next, thermodynamic process. So you know that the properties intensive, extensive, what is system surrounding and what is open, closed, isolated system and what is homo and heterogeneous system. Okay, and what is surrounding, what is boundary. Now we are going to study this thermodynamics process which is happen during the thermodynamics. So the thermodynamic process means the method of process we used here to modify the system or it is produce some changes in the system. That process or that method is known as thermodynamic system, thermodynamic process. So you can take the process like heating. When you heat, it will absorb the heat and rising the temperature. When you boil, it absorbs more amount of heat and it is reach into the higher energy level and the molecules, it's the kinetic energy of the molecules is also higher. And cooling process, when you cool that, all the molecules in the lower temperature, so that is cooling. And when you freeze that, it will be in the freezing form and it is the distance between that it's reduced. Okay, so the distance between the molecules will be reduced. And the expansion means it is elaborate the volume, and expansion means it is elaborate the molecules which is present in the system will elaborate. And compression means reducing the volume, applying the in varying that variation of the temperature and pressure. Fusion, vaporization, boiling and freezing. So these all the process, it's under thermodynamic process. To understand this all the process, we categorize that some process under this thermodynamic process. So first process is reversible process. Reversible process is one of the important process of thermodynamic process, which means the initial stage of the reaction can obtain or we can produce that initial stage of reaction from the product of the reaction. Okay, so we can retain that reaction from the product to, we can convert reactant to products and also product to reactant. This is reversible process. This is reversible process, and this process is undergo some conditions like, first, the process should be occur infinitesimally slowly. It is must be a slow process. Okay, then what is the second condition? The second condition is in throughout the process, in that full process, conversion of reactant to product to reactant, that system and the surrounding both should be in the equilibrium. Equilibrium means what? You are given here two gives, right? Two arrows. You can write this. Instead of this, you can write reactant, product. So both are in reversible reaction and they are in equilibrium state. Means what will you write? Half of the arrow. Okay, write the arrow like this, write the arrow like this, half of our arrow, which means first reaction, reactant to product, reactant to product. We neglect that side, this side. Okay, so we written only this half of the arrow. Then product to reactant. What is the next one? Product to reactant. Next arrow. So you should write like that. Product to reactant. So this is denoting, or this symbol is denoting that this reaction, it is in the equilibrium. Equilibrium state. Okay, so when the reversible process will occur, the reactant and throughout the process, it is a slow process, and second, throughout the process it must be in the equilibrium state. That means this is condition for the reversible reaction. How reversible reaction is reacting, or how it is happening, or what is reversible reaction. Reversible reaction means can produce the reactant from the product. Okay, we can produce reactant from the product is known as reversible reaction. So the definition for the reversible reaction is the process in which the system and surrounding can be restored to the initial state from the final state without getting any change into the thermodynamic properties of the universe is called reversible process. So there is no change in the thermodynamics properties. So there will be no change during that reversible reaction. Okay, so this is reversible reaction. The next type is irreversible process or reaction. Irreversible process. Irreversible process, it is opposite reaction or opposite process of reversible process. What you learn from the reversible process, the system and the surrounding will restore from the initial to the initial stage from the final stage. Okay, so in the irreversible process, the process in which the system and the surrounding cannot be restored to the initial stage from the final stage. So we can't produce the reactant from the product, but we can convert reactant to product. So we can convert this reactant to product, but we can't convert this product into reactant without getting any changes in the equilibrium. But so this process is known as, this type of process is known as irreversible process. So most of the process which is going on in the universe, it is irreversible process, and there is a condition for the irreversible process. During this irreversible process, the reactant and the product, it should not under the equilibrium state. It's not undergo the equilibrium state. That means this type of reaction will not happen. So it is not undergo the equilibrium state. Okay. So this is irreversible reaction. It is opposite of the reversible reaction. So we have completed only two processes of the thermodynamic process. We can look at this remaining process into the next class. Mark questions. Page number 188. First you write the types of system by depending upon the nature of boundary. That is depending upon, this question is depending upon the nature of physical and chemical properties. Okay, it is physical and chemical properties. And the second types of system is depending upon the nature of boundary. So you have to write these three. Open system. Write first separate question like what is open system? What is isolated system? You have to write isolated system with example. Hot water containing thermoflask. Okay. Then what is closed system? Up to here. and example. Then what is open system? The underline and example up to here. Okay. When they asked to write the types of system and differentiate the types of system, then you have to write fully from here to here. Okay. Then write it. What is intensive property? Intensive property, mark this with two example. And what is the extensive property? It is also with two example. Then what is reversible process? In this reversible process, you have to write what is reversible process. If they ask what is reversible process, then you have to write this up to here for 2 mark. When they ask this question for 3 mark, you have to write the important conditions. Firstly, up to here you have to write the 2 conditions with the 2 condition. And irreversible process also the same one. Write irreversible process. When they ask this in 2 mark question, when they ask in 3 mark question, you have to write fully. Okay. Thank you students. Study well.